Good morning, everyone. My name is Christian Maraglia, and I serve as the Applications Engineering Manager at Fujipoly America's Customer Engineering Resource Center. Joining me today is Mr. Yuji Yoshida. Mr. Yoshida is our R&D Section Manager at the Fujipoly Technical Center in Japan. Yoshida-san leads our technical team of research and development engineers, driving innovation and developing new technologies that shape the future of Fujipoly's products. Our topic for today is going to be rethinking waste and how Fujipoly is turning scrap into sustainability. The environment and sustainability has become a priority for companies across all industries. Our customers are increasingly concerned not only with how the product they use impact our environment, but also with their impact as they reach end of life. Questions such as, will this product end up in a landfill or can it be recycled, are shaping purchasing decisions. What happens to an old device once it's reached the end of its life or its useful life has real consequences for our environment. The reality is that every product we design and every process we use leave an impact. As engineers, innovators, and problem solvers, we have a responsibility to minimize that impact while still delivering the performance and reliability our customers expect. For us, sustainability isn't just about meeting regulations on a checkbox, it's about thinking long-term. How our materials, manufacturing process, and supply chains affect not only today's projects, but also tomorrow's world. By prioritizing environmental responsibility, we're working to reduce waste, improve energy efficiency, and explore recycled and more sustainable materials. We believe these choices matter, not only to our customers who increasingly value environmental conscious solutions, but also to the communities we live and work in. This commitment to sustainability aligns with our company values. It ensures that as we push the boundaries of performance, we're also hoping to create a future that is cleaner, more efficient, and more sustainable for everyone. So before we jump right into the presentation, I'd like to give everyone a little bit of background on Fujipoly, especially for those of you who are not familiar with us. Fujipoly was established in 1978, specializing in the secondary process of silicone. So what that means is that we take silicone in its many forms and enhance its properties to achieve characteristics that you may not normally find in silicone. So things including thermal conductivity and electrical conductivity are very common. We're best known for our Sarcon thermal gap filler products, but we also excel in molding and extrusion, producing high quality silicone products. We have extensive experience offering customized solutions tailored to specific application needs. Our headquarters and technical center are located in Nagoya, Japan, where much of the R&D and material development takes place. Our Fujipoly Japan factory is situated in Toyota City. Since our establishment, we've expanded significantly, establishing a substantial global footprint, both sales and in manufacturing. What sets us apart is our borderless strategy. We support customers wherever they are. For example, if you're designing a product in the Bay Area but need samples in Taiwan, we can coordinate activity and provide support throughout the entire process, from the initial inquiry to manufacturing and product sustainment. We also have manufacturing facilities in the US, Thailand, China. We've recently opened up a new facility in the Netherlands, and we have manufacturing facilities in Singapore. Our efforts to improve sustainability are not something we just started. In fact, this has been a focus for several years. What we learned is that even small changes, whether in the way we manage our facilities, design our products, or support our teams, can add up to making a big, meaningful impact. It's about taking consistent steps forward, knowing that each improvement helps us move towards a more sustainable future. Making efforts to reduce our impact on the environment often begin by simply paying attention to our own activities and looking for ways to improve. Sometimes, though, it helps to bring in someone from the outside who can spot opportunities we might overlook. In the case of sustainability, partnering with third-party experts provides a fresh perspective along with the experience needed to guide meaningful improvement. For example, our facility in New Jersey has been undergoing auditing and identifying ways to improve our impact. Something we quickly identified as a way of improving sustainability is simply reducing paper waste, or eliminate it if we can. Anyone that's worked in an office environment knows that paperwork is part of daily life and administration of any department. All Fujipoly facilities have been implementing a program to digitize documents when we can. This helps significantly reduce the amount of paper waste. Energy saving measures, of course, have a tremendous impact. Sometimes something as simple as replacing high energy consuming lighting with LED lighting has significantly reduced our energy consumption. We have implemented this at our facility in New Jersey and one of our largest manufacturing sites in China. Converting to alternative forms of energy production, such as solar power, can significantly reduce the environmental impact of our manufacturing operations. At Fujipoly America, we're putting this into practice. Our New Jersey facility will be relocating to a state-of-the-art site in the coming year, and part of that move includes the installation of solar panels to support clean energy use. As a material manufacturer, there where we have the greatest impact on the environment is through our direct manufacturing activities. The most significant factor here is scrap generation. While we always strive to keep scrap to a minimum, some amount is unavoidable. Scrap can result from non-conforming material that does not pass inspection, from the inherent byproduct of the manufacturing process, and from the conversion of sheet stock material to die-cut parts. This last step is an essential part of delivering finished products, but it also produces unavoidable scrap that carries a significant environmental impact. It's important to note that scrap doesn't only come from products themselves. The complementary materials that go along with our products, such as liners, which are an essential part of thermal gap fillers, also contribute to our overall scrap volume. For us, this often means PET waste, since nearly every thermal gap filler we manufacture includes a PET liner. While these liners are critical for handling, processing, and protecting the material, they do add to the environmental footprint we're working to reduce. With that, I'd like to introduce Mr. Yuji Yoshida, our R&D section manager at the Fujipoly Technical Center.
Thank you, Christian, and thank you to everyone who is joining us on this webinar. Hello everyone, my name is Yuji Yoshida, and I'm part of the R&D team here at Fujipoly. Today, I'd like to share how we are exploring ways to turn scrap into sustainability. As we begin, let's first look at the key drivers behind our environmental initiative. I'll show you three of the main drivers related to the tin market. Electrification and renewable energy are boosting demand, especially in EVs and power electronics. AI and data center are increasing power density, which drives the need for high-performance cooling. Overall, the tin market is growing over 8% per year. Production volumes are rising, and so is the amount of tin scrap being generated. The second driver is sustainability. OEMs increasingly require information on CO2 footprint and material composition. As an industry like packaging, automotive, and electronics are advancing recycling, but the tin sector is still behind. The third driver is regulation. In the US, the SEC now requires mandatory climate reporting, and OEMs are pushing for Scope 3 emissions reduction and carbon neutral supply chains. Similar initiatives are underway in Japan and the EU. But briefly speaking, the tin industry, currently behind in circular economy practices, may soon face strong pressure to accelerate sustainable innovation. Let's look at the sustainability issues related to tin products. While tins are often labeled as sustainable, because they contribute to environmentally friendly products, it is extremely difficult to make tin itself sustainable. Most tins are made from sunsetting materials like silicone, which makes them difficult to recycle. Recycled materials generally suffer from property degradation and high costs, which is a major challenge for high-performance products such as tins. Furthermore, there are no existing case studies, and customers typically do not expect sustainability initiatives for tins. Finally, these challenges mean that tins products are still far from being truly sustainable, despite the growing market demand and regulatory pressures. Of course, there are challenges in addressing sustainability. Our main product, pad-type tin, has both pros and cons. It helps minimize waste for customers. But manufacturing generates significant scrap, such as molding flash and material loss when cutting to shape. In some cases, over 40% of the material can become waste. On this slide, you can see the manufacturing process for our part-type team. The main steps are mixing, molding, cutting, and then implementation at the customer's side. Most product flash or scrap is generated during molding and cutting. In addition, we also have some scrap from auxiliary materials such as PET film used in the parts. In order to come up with a method to recycle our silicone products, we need to consider three main areas: chemical, mechanical, and thermal. Chemical treatment can depolymerize silicone, but typically requires highly alkaline solutions, creating environmental concerns and leaving inorganic fillers as residue. Mechanical treatment is impractical because the gel-like tins can be crushed like conventional rubber. It makes handling and property control difficult. Thermal treatment combusts the material in the presence of oxygen, producing silica that can damage equipment. However, under low oxygen conditions, this issue can be suppressed, though the resulting low molecular weight siloxanes still need to be recovered. Taking these challenges into account, we selected thermal treatment as the most promising method because it enables the separation of silicone and the potential recovery of inorganic fillers. Here you can see an overview of Fujipoly's raw material recovering technology. As shown in the diagram, the process starts with tin flash, which goes through thermal treatment. After separation, you can see both the recovered fillers and the silicone byproducts. After thermal treatment, the fillers are hardened and clamped together, so we crush them back down. This process restores them to fine particles, similar to the original fillers. There are three key points to this technology. Point 1. Thermal conditions. By controlling oxygen concentration and heating rate, we prevent silicone combustion and maintain the surface condition of the inorganic fillers. Point 2. Gas recovery mechanism. Through a dedicated recovery system and temperature control of the piping, we can effectively correct low molecular weight siloxanes while preventing clogging from D3, which solidifies at room temperature. Point 3. Filler deglomeration. A controlled process is required to break down the agglomerated fillers without damaging the original primary particles. Finally, one of the challenges of this method is that aluminum hydroxide, which is often used in low thermal conductivity tins, dehydrates and changes its structure during thermal treatment, making it difficult to reuse. Recycling efforts can also be focused on the enabling products. Like the liners used in the thermal gap filler products, liners are critical in the manufacturing, packaging, and use of silicone thermal gap filler. In collaboration with a partner company, we've established a process to recover and reuse PET film scrap that's generated during molding and cutting. Thanks to this initiative, we've been able to cut down scrap by more than 1 ton every month. That said, PET film recycling isn't without its challenges. The films can be contaminated with silicone residues. Release agents are often applied as a surface coating, and there are multiple types of PET, which makes sorting and recovery tricky. To address these challenges, our process is specifically designed to tackle these issues and recover PET film efficiently for reuse. I'd like to highlight Fujipoly's proposed environmentally friendly manufacturing process. In this process, waste generated during production, including tin and PET film, is collected. The PET film is sent externally for reuse, while tin is separated and recovered into its components, inorganic fillers and silicone materials. The recovered silicone is reused externally as silicone oil, and the inorganic filler is recycled back as a raw material for tin. Each step of this process relies on key technologies. First, we design product formulations that take advantage of recycled filler. Second, we have a collection method that ensures the quality of waste, which requires sorting tin by product type. Third, we use our proprietary technology to separate and recover raw material. Together, these key technologies make the process work efficiently and sustainably. A common concern is how the use of recycled material might impact the performance and reliability of silicone products. I'd like to talk about the performance and the features of our recycled filler, which we obtained using Fujipoly's proprietary technology. Compared to virgin materials, the recycled filler has comparable thermal conductivity. It doesn't cause curing inhibition that often occurs with fillers in platinum-catalyzed silicone polymers. And it has good flow and packing properties. The particle size distribution remains intact, which means it can be used directly as a raw material for original tin products. In addition, its cost is comparable to or lower than typically thermally conductive fillers, like alumina. This allows us to achieve high environmental performance, including lower CO2 emission, while solving the common challenges of recycled materials in terms of both performance and cost. In order to ensure our customers' requirements are still met, we evaluated tin samples in which part of the filler was replaced with recycled filler. All the fillers used were aluminum oxide. The thermal conductivity remained the same, regardless of the amount of recycled filler included. Regarding hardness, tins with up to 50% replacement of filler show comparable hardness to the original material. However, with 100% replacement, hardness increases significantly. This is likely due to the recycled filler having lower fillability compared to virgin filler, treated with silent coupling agents. In practice, this difference is not a major concern because in a closed-loop recycling process, only partial replacement is expected. We also evaluated insulation properties and heat resistance, and the results were comparable to the original TIMs, confirming that the recycled filler can be used without practical issues. Let's look at the customer benefits of TIMs with recycled filler. Fujipoly's recycling process and the use of recycled filler allow customers to enjoy these products without compromising environmental performance, cost, or quality. First, they can enhance their life cycle assessment performance by using products with low CO2 emissions while maintaining cost and performance. Customers can improve their life cycle assessment scores. Second, the recycling process helps reduce the cost of high thermal conductivity products, allowing customers to obtain high-performance TIMs at lower prices. Finally, because these products are classified as post-industrial recycled materials, they support customers in meeting environmental regulations and achieving sustainability targets. We have completed the feasibility studies and established the key technologies. In 2026, we plan to introduce mass production equipment and launch first closed-loop products. From 2027 onward, we aim to gradually expand the range of applications for these products. Looking further ahead, we are working to establish the technologies and systems needed to collect and process various products, both from our customers and from the market. Also, we are conducting research on technologies to recycle aluminum hydroxide, which is widely used in EVs and other applications. Thank you for your attention. We look forward to discussing how these developments can benefit your projects.
Thank you, Yoshida-san, for all your efforts and for your presentation today. And thanks to everyone in the audience for your time. We are all investing in creating a cleaner environment. Improving our own activities while also building a supply chain that shares these same values is key to making real progress. If you're interested in continuing the conversation on how your company can strengthen its sustainability efforts through your supply chain and how Fujipoly can support you in that journey, please don't hesitate to reach out. My contact information is below. I'd be more than happy to discuss this with you and get more information if you're interested in discussing certain topics that may have not been covered today. We also have some time today for some Q&A. So if for some reason we don't get a chance to answer your question, we'll make sure we do that offline via email. And of course, like I said, you can contact me directly.